90 degree leading. So current always lags the voltage by 90 degree, which is also represented by this figure, and it also represented by this vector diagram. So by mathematical we also prove that, or by analysis we can say that voltage is all leading current, means current always lagging the voltage. Next is state advantages of three-phase system over a single-phase system. Now question for a 5 mark, state advantages of three-phase system. So there is so many advantage of three-phase system over a single-phase system. So we go with brief discussion. Now three-phase system is always small in size. If we design a two machine for a same rating, then the size of three-phase machine is very small compared to the single-phase machine. So one benefit is small in size. Second is low cost. If we design a two machine, a single phase and three phase machine for a same rating of power and voltage, then cost of single phase machine is three phase machine is very low compared to the single phase machine. So for a same rating, cost of three phase machine is very low to single phase machine. Why? Answer is in next. Again, it provide power factor of three phase system is much better than a single phase. So power factor is improved in three phase system than a single phase system. So it is very advantageable to us. Now okay, good is rotating magnetic field. As we know that single phase motor is not a self starting, but a three phase system, a three phase machine is always self starting, because RYB three connections are generating rotating magnetic fields. That's why they are self starting. But in a single phase we have to provide some self starting mechanism, and again it becomes very costlier and complex. So three phase system generates rotating magnetic field. It has very less copper. Now what is the meaning of less copper? After generation and the distribution of three phase system, power transmission and power distribution will require a very less copper than a single phase machine. So use of copper wire is less in three phase system, which is again benefit to the cost of designing. Now flexibility. The single phase can be obtained from three phase, but the three phase cannot be obtained from single phase. So good is that in three phase we get R, Y and B. So if I want to only the one phase I want to use, then I use VR with respect to neutral, then it is a single phase. But in three phase system cannot be obtained from the single phase. So it's called good flexibility. We can get both benefit from the single phase, three phase and single phase. So three phase is very advantageous to the single phase. And third is provide steady output. In three phase system we get steady output. So for a 3 mark we have to go with this 6 benefits, and these are the good benefit. Now question number 4. An alternating current is represented by I equal to 70.7 sin 314t. Find 5 quantities. First is maximum value, second is frequency, third is RMS value, fourth is average value, and the value of current after 0.01 second. Here alternative quantity is given in the data, which is I equal to 70.7 sin 314t. From this one equation of current we have to derive 5 quantity: maximum value, frequency, RMS value, average, and value of current at a given time of 0.01 second. 5 quantity and 5 mass. Okay, so go with example. First is maximum value. So we write down the equation and go with the answer. See, in data here already is given I equal to 70.7 sin 314 t. So as we know that current is given by I equal to Im sin omega t. Im sin omega t. Now comparing each and every value, we get the answer. So by comparing given data with this data, we got our first answer is maximum value of current. Maximum value of current. So simple, it is a maximum value of current. Im equal to 70.7 ampere. So first answer is maximum value of current is 70.7 ampere. Now second is ask for frequency. How can I get frequency? So by comparing these two terms, omega t and 314 t, easily I know that value of omega is 314. Value of omega is 314. So now what is value of omega? So in place of omega we write down 2 pi f equal to 314. I want to find out frequency, so 2 pi goes in denominator, 314 upon 2 pi. Now dividing 314 by 2 pi, we get answer of frequency is 50 Hertz. In calculator, if we divided this answer, then we get frequency is 50 Hertz. So simple, putting the value of pi is 3.14. See here 314, value of pi is 3.14, and as we put the value 3.14, 100 is gone up, 314 cancel, so 100 upon 2 and we get 50 Hertz. So simple, there is two quantity, maximum value and frequency. Third quantity is RMS value. As in previous slide we have discussed the equation of RMS. So I RMS equal to Im upon root 2. So we know that value of maximum current is 70.7 upon root 2. So as we know that value of root 2 is 1.414. Now dividing 70.7 by 1.414, we get Vrms equal to 50 ampere. So this is my third answer. Go for fourth one, the average value. Now what is the average value? The average value is given by I average equal to 2Im upon pi. So 2Im is maximum current. So maximum current value is again 70.7 upon pi is 3.14. After solving this equation, we get value is 45.03 ampere. Now average value is always less than by root mean square value, because average value is always, it is a 60% value, while it is a 70.7% value of maximum current. So 60, I near about 63%. So average value is less than the RMS value. To check our answer, we have to go with this derivation, this formula, that our RMS value always greater than our average value. So here RMS value is 50 ampere, average value is 45.03 ampere. That means our answer is right, and by checking we get our answer. And final quantity is current at time t equal to 0.01. So here time is given, time is 0.01 second. So I know that current is 70.7 sine 314 t. So 70.7 sine 314 into 0.01. Now this value becomes very nearer to the 0. By multiplying I get very nearer to the 0, or this becomes a value 3.14, and it gives value sine 3.14. It's equivalent to sine pi, and we know that value of sine pi is 0. So this complete term becomes 0. By observation, this complete term becomes 0, and so current at the time 0.01 second is becomes 0. So by comparing that, we get the value of current at this time is 0 ampere. So by this way, simply we can get our 5 value. The maximum value is 70.7 ampere, frequency is 50 Hertz, RMS value is 50 ampere, and average value is 45.03 ampere, and current at the time 0.1 second. So by put the t 0.01, we get answer is 0, because sine term becomes 0. So 70.7 multiply with 0, we get answer is 0. Simple calculation gives you 5 marks. Okay, next question is derive the relation for impedance of RLC series circuit. It is given for a 4 mark. So we will discuss about the equation of impedance of RLC series circuit. See in the next slide. This is the RLC series circuit. In that, one resistor is represent. Resistor is connected in series with the inductor, and inductor is connected in the series with the capacitor. These 3 series connections are connected in series with AC supply Vs. So now voltage drop across the resistor is given by VR. Voltage drop across the capacitor is given by Vc, and voltage drop across the inductor is given by VL, and current passing through the circuit is AC current, and value of AC current is Im sin omega t. So if we apply the KVL for the series circuit, I get the equation vector V equal to VR plus VL plus VC, because in series connection voltage drop across all these 3 quantity is equivalent to our applied voltage. So V is equal to VR plus VL plus VC. Okay, so let's go for the 3 condition in this series RLC circuit, and then we can get relation between the voltage. So 3 types of impedance we can get. go for the case number 1. In our circuit, if XL is greater than XC. Now what is the meaning XL is greater than XC? That means XL is inductive reactance and XC is capacitive reactance. So maybe inductive reactance is more than capacitive reactance. In that case, the VL is greater than VC. When inductive reactance is more than the capacitive reactance, at that time always inductive voltage is greater than the capacitive voltage. So VL is greater than VC. So resultant voltage is given by VL minus VC. Now as for the previous, we go with the derivation and we find the equivalent voltage. So equivalent voltage V square equal to VR square plus VL minus VC square. By taking the difference between VL minus VC, we get a resultant voltage. Now as per the Ohm's law, I put in the place of V I Z or I R. What I get? V square equal to IR square plus in the place of VL we put IXL, and in place of VC we put IXC square. So term becomes V square equal to IR square plus IXL minus IXC square. In these three terms, by taking out the I common, we get I taking out, then it becomes I square. So put the value, I get in place of V I put IZ, then it becomes I square Z square. Taking I square common, R square plus XL minus XC square. Now I square is common on the both side, so we cancel out the I square. So equation, now taking square root on the both side, I get Z equal to R square plus XL minus XC square. So case when the inductive reactance is more than capacitive reactance, the impedance is given by under root R square plus XL minus XC square. Okay, thank you.